we going to look into simplification. But this one is basically on what you have gone through for your law, for your rules, and for your De Morgan Theorem. So over here you can see you have the simplify this expression. It asks you to simplify. So you were given with all 12 rule. Of course, in your test, in your final exam, you're not going to be provided with all this. You need to remember. So from all of this, you can use any rules and any law. Also, if let's say you have like bar, you need to convert it using your De Morgan theorem. So last time, if I didn't give you this, basically it's very easy because you already go through several times on simplification. Here you can see you not only sometimes you not only follow the similar rules. So you can see over here, step number 2, you're going to apply rules number 7. Step number 3, you apply rules number 5. You sometimes no need to follow exactly similar things. That's why you are freely to use all these rules. Sometimes you follow this rule, of course, but sometimes you didn't use this, but you use rules number 2. So let me show you the different way. Of course, this one, okay, for first time you were given this, right? So of course, you're going to make it to be AB, and then you multiply with AC, and then B plus B, you're going to get BB, and then you plus multiply, you're going to BC. So for this, you can like doing the simplification version using rules number 7, which is B dot B, you will get B. So that's why after that, you're going to get like this. So from this, you can see also you have several ways to apply. You can see this also, you can simplify, which is AB plus AB. You're going to get AB also. Rules number 5. You're going to get this term. And from here, you can use different other rules. But in this example, it gives you rules number 10. You can see rules number 10 here, A plus AB equal to A. A plus AB equal to A. Where is A? Where is AB? So this is A, this is A and B. So only you swap. Although it's like mentioned, it's quite like confused lah. You can see here, isn't this supposed to be A? No, it is. This A is referring to one variable, so you can assume like A equal to B here. So there is another A B means that B multiply with something variables here. So supposedly our B here is A. So you just swap, then you will get equal to A. What is A is B. This one, right? Our A is B. So we use the rules number 10, which is we already proved this in our module 4A. So no need for us to like show back how basically it's a good A. Look back at your 4A module, and over here we will get A plus AC. This is the in term of simplification. So please make sure back that I already give you the hint. Sometimes you don't know which and what is the answer for simplification version. Then that's why in your module 4B here, you're going to look into your care maps. But that's after we learn on SOP and pure S. So rules number 10 is apply, then you will get this simplification version. Now, if you did not apply rules number 10, you still can use different other rules. And from here, maybe you don't want to simplify, then you simplify at the end of this answer. It's okay because you can like swap any rules. No need for you to follow directly because every people having a different way to simplify. As long as at the end of the answer you will get the similar simplification version. Then over here, let's say I don't want to use rules number 10. How I can do? I can also do like this. Oops. From here, I want to simplify. Okay, I have B. I have A plus 1. How I get B, A plus 1? Because I have this B. B multiply with B, I get B. A multiply with B, I get AB. So similar, right? So I get B, A plus 1. What is A plus 1? A plus 1 is 1. So I can get my answer B plus AC. So there is a several way I mentioned, right? So no need to you to follow all this rule to get the simplified version. So maybe you can try to simplify by yourself as long as you know you will get this. Whether you are using a similar rules or you use a different one, which is I use rules number 2 here. So can you try to simplify it? From above also, you can also simplify. You can see here B 1 plus C. Oh, BC eh. Ah, correct ah. So over here you can simplify B plus BC. Then maybe you can simplify this one. You get AB plus AC plus B. So you can simplify it later on using rules number 5. So it's depend on you how you're going to simplify. Next, after you know how to simplify, you also already learn how to convert from your Boolean expression to simplify, and then from this simplify simplified version, you can come out with your logic circuit and your truth table. So from this truth table, you can also get your Boolean expression. From this logic circuit, you can also get your logic Boolean expression. So today, this one is just a recap, and there is another one example for you to do a simplification. Basically, why I don't want to like teach you how to basically follow step by step, because as mentioned, you can do the step number 2 at step number 4, and you can do like step number 4 to number 2. So it's depend on you how you going to simplify. As long as I ask you to try many time, exercise how to apply all the rules here, and we also already try several way to simplify. So please try to do this. Okay. According to the example, draw the logic circuit. Okay, this one is you were given with the question, the original, without looking at the simplification version. Please try to use your law, your rules, and also your theorem to get the simplification version. After that, draw the logic circuit from the simplification version. That is only a recap, which is extra, of course, which is you remind back your module to 4A. Today, we're going to look into the new things, which is SOP and POS. If you still remember last time, I give you F equal to 1 And if you still remember, let's say I have f equal to ab plus a bar b bar plus a bar b plus b bar a. Okay, let's say this example, okay. Macam semuanya satu je, tak apa. I give you example first. So over here, if you still remember how to draw truth table, A, B, 0, 0, 0, 1, 1, 0, 1, 1. And it teach you last time that if you have here is correct, means that you get the output 1. If this is correct, output 1 and so on. So I give you A equal to 0, A equal to 1. A bar equal to 0. Whatever you get bar here, it means 0. I teach you last time like this, right? So you follow still, you follow. You can see 1, 1. And then you have here 0, 0. 0, 1. Kenapa terbalik ni? B, wait A, B bar. Our A is 1, B is 0. So from here you can see if you have 1, 1, you get 1. If you have 0, 0, you get 1. If you have 0, 1, you get 1. And 1, 0, you get 1. So this is how you draw the truth table last time, right? But it is applied into SOP. Why SOP? Last time you always look into the SOP Boolean expression. Rarely you meet this term, like this figure. So this one is POS. And that's why last time I mentioned you that you going to find out how to get the truth table of output 0. You need to see the output 0. Last time I already mentioned. So here today you're going to meet that. For SOP, there is several condition which is similar you apply here, which is if A is going to be equal 1. Similar, if you get B, it's equal 1. But if you have bar, A will be 0, B bar is going to be 0. This is for SOP and your output will be F equal to 1. And then you draw at your table is equal to 1. But for POS, what is POS? Later on I will inform you. But I want you to see the overview first. POS, it is different, which is A equal to 0, A bar equal to 1. See over here? It's different, okay? And if let's say you have B equal to 0, B bar equal to 1. And your output will be 0. So I give you example here. If let's say you have POS, a simple one only. I have POS, okay? Let's say I have F equal to A plus B dot multiply A bar plus B. Okay, finish. This is my POS. Later I show you how to look into POS and SOP. And from here, I get this as a term 1, sum term. Sum term 1 and then this is term 2. Term 1, I have A plus B. What is A plus B? I need to remember A equal to 0, A bar equal to 1. And my value will be 0, 0. So I draw my table here. 0, 0, I will get 0. Why 0? Because POS output will be 0. Next, I have A bar plus B. A bar equal to 1. A will be 0. So B will be 0. So at this part, 1, 0, I will get 0 for my POS output. The rest will be 1. If you have SOP, SOP F equal to AB plus A bar B. Similar, okay, but it is in term of SOP. So how the output look like? It's going to be 1, 1 and 0, 1. Why 1? Because A equal to 1, B equal to 1, and A bar equal to 0, B equal to 1. Slightly different because this is A equal to 0. This one A equal to 1. Now my truth table here, I'm going to get F A B. When 1 1 is counting 1, oops, hey, 1 1 I get 1 here, 0 1 I get 1. Ya Allah. So the rest will be 0. So this is example. Later on you will see again, but I just want you to have the overview. So no need for you to confuse. Now, what is SOP? What is POS? SOP means sum of products, which is you sum, see, of your product. This is product 1, this is product 2, which is we call as product term. Product term is a term with a product, which is Boolean multiplication. You can see here A, B, C bar. You have multiplication and you have several variable inside that it called as a product term. Product, and then you have another product. So you sum it all. It's called sum of product for S or P. This is the normal Boolean expression. Last time we always use this looks. We play around with this look, which is S or P. Now, slightly different, you can see you have POS, which is product of sum. You have all sum. Sum means this is sum 1, this is sum 2. Sum is a term with the sum. See? Term with the sum, which is you have all the term and you sum it together. And you're going to multiply with another sum term. So you multiply with another sum term, multiply with another sum term, and etc. So this look will be your POS. Can you see the differentiation between POS and SOP? Okay or not? This
Yes, doctor.
okay, thank you. So because you can directly see it, because it's easy for you to differentiate, let's see first thing on SOP. So from SOP here, you can see SOP when two or more product term are sum. Means that you have at least one sum. You can also have a single variable. Let's say you have x equal to a plus ab plus c. This is SOP. Although this one is single variable, this one is single variable, but this is one term. This is one product term, one product term, one product term. Although in your product term, it's going to have only single variable. And there is another one more thing that you need to know. In SOP, similar to our Boolean expression, we cannot let it to be this part, which is single over bar to multiple variables. We need to have a single bar to single variable. If this one, you need to do the De Morgan theorem. Okay, that is SOP. And in terms of looks on the circuit, how the circuit will be look like. So this one is also easy because you already know how to draw the circuit. This one you're going to multiply, which is AND gate. This one you're going to multiply, which is AND gate. This one is also AND gate. And all this product term, you're going to add. adding sum, which is OR gate. Later, you're going to see the differentiation with the POS circuit. So before we go and take a look into the SOP circuit, later we go back to this slide. Let's take a look into the POS first. So for POS, you can see when two or more sum, this is one sum, two sum, are multiply. See? So you multiply this sum, you multiply this sum. This one, there is a three sum over here. And still it's mentioned if you have single variable also, it's going to be POS. Let's say I have A plus B, multiply with A, multiply with B, multiply with B plus C. So this is one sum, this is one sum, with this one sum. You multiply it together, it's called as POS. And again, similar with SOP, you cannot have one single overvar to multiple variable. You need to simplify it using your De Morgan theorem, of course. And because of this, you need to have at least you're going to have the single bar over single variable only for your POS. Okay, now this is the circuit that I mentioned. You need to see when you have a sum term, you're going to multiply. So of course, you're going to have sum first, which is OR gate. Sum first, you're going to have OR gate, and multiplication, you're going to have AND gate. So you're going to multiply dot dot all your sum product. Different with the SOP, it is AND gate first, and then you have OR gate. But for POS, you have OR gate. Then you're going to have AND gate. So that is the difference for the circuit loops. Is it okay for this part? And let's take a look into the exercise here. Convert the following Boolean expression as to the SOP form. Sum is okay, that this it is POS. This one is also having a POS, although this part going to have SOP. But you need to like making it a full SOP version. This is also not SOP yet because sorry, because you have the single bar over a multiple variable. So let's take a look one by one. You can have over here A, B plus B, C, D plus B, E, F. Okay, now it is a SOP. It's very easy. Here you need to multiply it. A, B plus E, C plus E, D plus B plus B, C plus B, D. This is another SOP. Okay, over here we need to apply the De Morgan theorem. We're going to get A plus B bar dot C bar bar. And we have A plus B multiply with our C bar. We need to convert it to B SOP. A C bar plus B C bar. So then get the SOP. This one is POS. This is SOP. So let's take a look proper way. You can see, for example, number one, you can directly convert it. This one is second. So this is example one. You just multiply B with the CD and then B with the EF. You get the SOP already. Here you multiply with this one Here you multiply with this one. Here you multiply with this one. You will get A, B, B, sorry. A, B, A, C, A, D. And then B you multiply with B. B you multiply with C. B you multiply with D. You get the S of P. The third one, you get this one, you're going to use De Morgan theorem. No need for me to teach you again how to get from adding. You go to the multiplication, and then you have bar and bar. This is De Morgan theorem. And from here, this is POS. You're going to multiply A with C bar, you get this. B with C bar, you get this. Now it is S or P. So any question for this? No question? I'm going to directly go to next. So you need to know what is standard for your Boolean expression. Standard, okay. Let's say you have x equal to a plus bc plus ab. Is it a standard Boolean expression or not? You're going to see for this Boolean expression, there is altogether 3 variables. So in all the product term, you need to have 3 for SRP. This is product term, right? So for SRP, if you have all 3 variables, you need to have 3. Similar to POS. If you have 3 variables, all the sum term need to have 3 variables. So how to convert the simplification version to the standard version of Boolean expression? If SOP is very easy because you just apply one rules, which is A plus A bar equal to 1. Why 1? Later I inform you. For POS, you need to remember there is 2 rules. Rules number 8 and rules number 12. You need to apply these 2 rules to get the standard versions of your Boolean expression. Okay, Y1, Y0. And why this rules number 12? Let's take a look into SOP. How the SOP look like? X equal to A plus B, BC. Okay, BC. So from here, if I have A, I multiply with with B plus B bar. Is anything's happened to this? This is basically 1. So any value I multiply with 1, I get a similar value. If I have 10,000 multiply with 1, I get 10,000. I have 100 multiply with 1, I also get 100, which is it doesn't affect my value or magnitude. That's why I will multiply with 1 using the rules number 6, just because I want to add b. I want to add variable b to my product term for SOP. So if I have x equals to a plus bc, at this part, I missing B and C. At this product term, I'm missing A. So, okay lah, I'm going to show you very simple one, right? So, I want to make this to be standard. So, I'm missing A only. How I'm going to get the standard? I'm going to get BC multiply with my A plus A bar. So, I will get B, I will get AB and B. Ya Allah. A bar B. Yeah. Sorry. This one in multiply. See, if I didn't put the factorize, sometimes I also confuse. BC will multiply with A. BC will multiply with A bar. So I will get ABC plus A bar BC. This is a full three variables, mean that it follow the standard. Later, you're going to apply the similar thing to A. I'm going to multiply A with B plus B bar. I will get AB plus AB bar. Still, I can see my product term is missing C. So, I'm going to multiply A, B with C plus C bar. And AB bar plus C plus C bar. So from here, I'm going to multiply. I'm going to get ABC plus ABC bar plus AB bar C plus AB bar C bar. So I have full version of three variable. I combine it together. I get the standard version of my SOP Boolean expression. It's going to apply similar thing for POS, which is you need to have all variables. But later we look into this, okay? We're going to look into the example of SOP first. So let's take a look for the example here. To convert the product term of SOP. Okay, this one you can get read and go through all of this. Okay, convert the Boolean expression standard SOP to the standard SOP. You have term 1, term 2, term 3. For term 1, you are missing D variable. For term 2, you missing C and D. For term 3, it is full standard SOP. Now, how I'm going to do A, B, C, A, B bar, C to full standard? So, I'm going to apply the rules number 6. 6, 6. I'm going to multiply it with 1. But in terms of 1, I'm going to multiply with D plus D bar, which is equal to 1. D plus D bar. I'm going to multiply it. I will get A B bar C D plus A B bar C D bar. If I didn't have enough one variable, I will add another 2. So now I'm missing 2 variables from A bar B bar. First, I will do one time. I'm going to multiply with my C plus C bar because I'm missing C. So I'm going to multiply it. I'm going to get A bar B bar C plus A bar B bar C bar. Still, it is not occupied 4 variables. What I need to do, I'm going to multiply this with my D plus D bar. And I'm going to get A bar B bar C D and plus A bar B bar C D bar here. A bar B bar C bar D. Another one more time. A bar, B bar, C bar, D bar. Everything is full for variables. It is follow standards, and I can see if I'm missing 2 variable, I add another 4. If missing 1, I add another 2. If missing 2, I have another 4 to add on. So my full SOP, standard SOP, I'm going to get, I've picked this, A, B bar, C, D. I pick this one, plus A, B bar, C, D bar. Okay. And I've picked this, A bar, B bar, C, D, plus this, A, B, C, D, plus, I pick this one, A bar, B bar, C bar, D, and this one. And lastly, this term 3, A, B, C, D. This is my SOP. So is there anything that's similar? Blah, 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 blah. No. So this is my standard version SOP from this Boolean expression. You just apply, multiply several times using your rules number 6. Depend on what variables that you are missing. If you're missing C, then you multiply with variable C. If you are missing D, you multiply with variable D. So in proper way, you can see here what variables you have A, B, C, D. What is missing? For term 1, you are missing D. For term 2, you are missing C and D. Complete the following using the rules number 6. So here, first term 1, you're going use to follow the rules number 6. You multiply with the missing variables, which is missing D. So you multiply A, B bar, C, multiply with D, you get this. And you multiply again, you will get this. Finish. One variables, you have 2 terms. And if you're missing 2, first you're missing C, you're going to get this one. So you do one by one. And then you'll repeat again the similar things. You multiply with D bar. D plus D bar. So your final answer, if you're missing 2, you're going to have 4 product terms. And term 1, term 2 finish, and you combine with another term 3. So that is your final answer. Now there is another one, it's very simple one. Determine the variable SOP expression and convert the expression to the standard SOP. So you have SOP equal to AC bar plus BC bar. Over here, you can only see this part, you are missing B. Here, you are missing A. It's easy for me to do. I have term 1, AC bar. I'm going to multiply with my B plus B bar. Then I get A, B, C bar plus A, B bar, C bar. Finish one. Here I'm missing 1, which is A. BC equal to BC bar multiply with A plus A bar. I will get ABC bar plus A bar BC. C bar. So this is my answer. Now I'm going to combine it together. My SOP equal to ABC bar. This one plus A, Allah, A, B, bar, C bar plus A, B, C bar plus A bar, B, C bar. And I can see, mana yang salah ni? Okay ni. I can see this and this is similar. So I'm going to use a rules number 1. I forgot already rules number 1. So you just apply it to be A, B, C bar because it's similar plus A, B, C bar, bar plus A bar, B, C bar. So this is your standard SOP form from this one, from your Boolean expression here. Senang ke tidak? Is it easy or is it difficult? Any question?
Doctor, if we got the same variable for like ABC bar, so we only do one, right?
Yes, follow your rules number. I forgot lah the rules number. This one.
Number 5.
Yes. If it is similar, then you get a similar things.
Oh, okay.
So this is your simplification version. Any other question? How about here it's mentioned already. Rules number 5. So if there is no question, we're going to move to why under SOP again? Under SOP. Okay, let's take a look into this. Last time there is several students ask me after finish class. They ask me about their curiosity. Why? Because if you still remember, if you have like this F equal to A, B bar C. Okay, from this, right? I mentioned to you that if you have this one, your truth table, you will get F equal to 1 where you have 1, 0, 1. Then you will get like 0, 1, 0, 1, you get output F equal to 1. But the students inform me, Doctor, isn't it that it will be multiply, which is n get. If 1 multiply with 0 multiply with 1, you will get 0. So how come your output will be 1? So for those who already understand, it's okay. But for those like still questioning that things, so here there is an explanation for this one. So let's take a look how. Okay, this one. Please remember on the sum equal to addition, 1 plus 0 is equal to 1. 0 plus 1, you will get 1. 1 plus 1, you will get 1. And for SOP, you're going to divide into product. This is product. Inside the product, you're going to have several variables. Okay. This is your SOP. F equal to A, B, C bar plus A bar, B, C bar. And for SOP, I already mentioned, you're going to follow this rule. A equal to 1, A bar equal to 0. Your F will be 1 for your output, right? So you have several things to see. This one is all. Means that either one, if this is 0, this is 1, you will get 1. If this is 1, this is 0, you will get 1 for your output, right? If this is 1 and this is 1, you will get 1. So there is several condition for you to meet and you will get your output as a 1. So now let's take a look how to justify this. I have this And let me draw the truth table so you can see basically how you can relate 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So I have all 8 possibilities. This is my F, this is my A, B, C. Last time I just inform you, if you can see the bar, like F equal to A, B bar plus A, B. If you have a bar, you assume it's to be 0. If it is there is no bar, it's going to be 1, 0. And this input, your output will be 1. So how basically to justify this? Now I'm going to show you. Let's we apply. First scenario, we have A equal to 0, B equal to 0, C equal to 0. Okay, don't see the rest, okay? We look only at this. What is our output? We have 0 for A, 0 for B, and 0 for C, but our C is bar. Get it? 0 for A, 0 for B, 0 for C, but here in our Boolean expression, it is bar. So I put bar. Now I apply, add here. This one is multiplication, multiplication. I have A is 0, and then this is a bar. B is 0, C is 0 with the bar. So I make it like 0 dot 0 dot 0 bar will be 1 plus 0 bar will be 1, 0, 1. If I multiply this, I will get 0 plus 0. 0 plus 0 is what? Of course, you know it is 0. That's why you get 0 here. Okay, that is first. Second, I just want to justify how basically you can like direct apply the last time we learned. Now, second scenario. Let's check our answer. Our answer, my C now is 1. The rest will be 0, right? Okay. I apply A is 0, B is 0, C is 1 with a bar. Plus A is 0 with a bar, B is 0, C is 1 with a bar. I will get whatever multiply with 0, I will get 0. Multiply with 0, I'm going to get 0. My answer will be 0. So I put here as a 0. Done. Number 2. Third. Let me check my third one. My third one is 1, 0. A is 0, B is 1, C is 0. So how I'm going to apply? A is 0, B is 1, C is 0, and my Boolean have bar. Plus, A is 0, B is 1, C is 0 bar. So now I solve this. I'm going to get 0 multiply with 1 multiply with 1. I get 0. Here, adding with 0 bar will get 1 multiply with 1. 0 bar will get 1. So I will get 1. Now 0 plus 1. My answer will be 1. So from here I can get 0 plus 1. I will get 1. Is it correct or not mine? 0, 0, 0. Supposedly I get this. Is it mine? 0 is 1. And then 1 will be 1. E, B. Okay, correct. So you understand, right? This state. Now, I go for, if you didn't understand, please stop me, okay? Now, I go for my fourth one. My condition will be 0, 1, 1. 1 and 1. I check one by one. Here, A is 0, B is 1, C is 1 with a bar. Plus, A is 0 bar, B is 1, C is 1 bar. I solve the solution 0 multiply with 1 multiply with 0. My answer will be 0. Add with 0 bar will be 1, 1 will be 1, 1 bar will be 0. My answer will be 0. I add 0 plus 0. My answer will be 0. So I put here 0. This one is manually. I do it one time per one time. Okay. One by one I do. So now I have the fifth one. 4, 5. I have condition of 1, 0, 0. 1 for A, 0 for B, 0 for C. So I apply into the Boolean expression. I follow the Boolean expression. A will be 1, B will be 0, C will be 0 with the bar. A is 1 with the bar, B will be 0, C will be 0 with the bar. So I get here 1 multiply with 0 multiply with 1, I still get 0. I add with 1 over bar, get 0, 0 and 1. I multiply it together, I still get 0. That's why my answer will be 0. Next, I have the 6. My sixth one is 101. 101, I will get 1 for my A, 0 for my B, 1 for my C with a bar, plus 1 for my A with a bar, 0 for my B, 1 for my C with a bar. Here I will get 1.0.0 plus 0 plus 0 plus 0. Here I will get 0 plus 0. My answer will be 0. 7. 7, I will have. Okay. My one will be 110. 1 for A, 1 for B, 0 for C with a bar. Plus, this one is multiply, right? 1 for A with a bar, 1 for B, 0 for C with a bar. So here I'm going to get, why? I think there is one missing over here at this part. Not missing, wrong. So over here you can see I have 1.1.1.1 because 0 bar, right? I get 1 plus 0.1 dot, ya Allah, dot 0. So here I get 1 plus 0, I get 1 for my answer. So here is 1. So lastly, number 8. For the last one, I'm going to get, here is 1, 1, 1. So let me see. 1 for A, 1 for B, and 1 for C. Plus 1 for A, 1 for B, 1 for C. This one is 1, 1, 0, 0, 1, 0. Why 0 is a bar. Ya Allah, saya tertarik je ni. So this one is multiply. I get 0 plus this one is multiply. I'm going to get 0. My answer will be 0. That's why you can see here This will be 1. This will be 1. With the proof manually input into your Boolean expression. So you get what? 0, 1, 0. And another one is 1, 1. Ya Allah. 1, 1, 0. What is 0, 1, 0? If A is bar, is 1 is B, and C is bar. Why? Because it's follow this one. If 0 is going to bar, there is no bar, it's going to B, and B, there is B. So it meet this condition. You can see here. Another one is 1, 1, 0. 1, 1, 0 is will be A, B, C bar. See this one? So you prove now it's correct. So the one like saying, doctor, this one is A dot B dot C bar. Supposedly you need to have like all it's to be 1, 1, 1, 1 to get 1. But why over here it is like 1, 1, 0. And this one is 0, 1, 0. Then you said the output will be 1 at this. So you try to see, you put input here one by one, then you prove that no need for you to do manually 1, 1, 1. You just follow this term for SOP. If there is a bar, it means 0. So for this point, you will get 1, 1, 0. If there is a bar over here, it is 0. So only at these two input, your output will be 1. The rest will be 0. So any question? Clear or not? I will just show you one by one.
Clear, clear, doctor.
Clear,
Clear.
doctor.
Clear, doctor.
So thank you. You can see also if you are given like this, right? F equal to AB, blah, 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 blah. Then how you going to get a truth table directly without you need to like do one by one, 0, 0, 0. What is the output? 0, a plus, and then multiply. So it's going to be like very long to you. So that's why kenapa ni? That's why you can like directly jump to your conclusion. A, B, C, D, 0, 0, 0, 0. Malas lah nak tulis. Too lazy to do. And then you have F. If you have 1, 1, 1, 1, you get 1. You have 1, 0, 0, 1. 1, 0, 0, 1, you get 1. And here is 0, 0, 0, 0, you get 1. The rest will be 0, 0, 0, 0, 0, 0, 0, 0 over here. So directly like 1 minute, then you can draw the truth table already. So here, this one, you can try to do it. It's basically apply the similar things that I showed you. If you have like 1, 1, 1, 1, if you have 1, 1, 1, 1, then you get 1. You're adding with whatever number here, you still also get 1. So if let's say for this condition, 1, 0, 0, 1, you bar and you get 1.1.1.1. So you still get 1 for your output, similar to this. If you like, I think it's like very confusing if you didn't know how to do it at the start. Then now if you know it's basically you can try to apply the value, then you say okay, then understand the value of 1. Why you get the 1 for the output. So from the SOP, generate the truth table. It's very easy. You tengok je, you can just see this. Oh, I will get 1, 1, 1, 1, output 1. So my truth table, 1, 1, 1, I get 1. A, B, C, D, F. And at my 1, 0, 0, 1, I get 1. This one is 0, 0, 0, 0. I get 1. The rest will be 0, 0, 0, 0. This is your truth table. Very easy one, which is applying the SOP again. I shows yours. A equal to 1, A bar equal to 0. Your output will be 1. Then you get very quick truth table. Now we go to our POS. For the POS, first thing what you need to do, of course, before you can draw the truth table. If let's say over here you are missing D, you cannot get this output like 1, 1, 1. What is this? What is the D here? Is it for 1, 1, 1, 0, you get 1? Is it 1, 1, 1, 1, 0, you get 1? So you don't know, right? So that's why you need to multiply this with D plus D bar to check your answer to get the standard version. From the standard version, then you can draw your truth table. If it is still not standard, you cannot get the output. You cannot like convert it directly. So similar to your POS, you need to do standardization. How to do it? So to do it, you need to follow. You need to follow the rules number 8 and 12. For the rules number 8, you're going to have A multiply with A bar equal to 0. Why Just now SOP, you multiply with 1. So here, why is 0? Because POS is different. You have these looks. A, B, sorry. A plus B multiply with A plus B bar. Okay, like this. I need to have C plus C. So this one is complete standard version because you have A, B, C. This one is not enough. So you need to add. You cannot multiply because POS is adding, which is sum. Sum, right? So you need to add. If you add 0 with this or any value adding with 0, nothing happen, right? Like nothing happen. So you need to see these rules to make it as a 0. So let's say I put here A plus B multiply with A dot, C dot C bar. Why? Because I add with 0. But I want these C variables inside my POS or Boolean expression. That's why I put here adding with 0, which is C dot C bar. So from here, after you have this one, clear view, tak cukup tempat. Where is it? Okay, here. A plus B plus C dot C bar. Now, how to solve this? Then there is another rules here. Rules number 12. A plus BC. This is my plus. This is my A. This is my B. And this is my C. Is it similar or not? Murid-murid sekalian? Is it similar or not? Similar, right? My A now is A plus B. My B now is C, and my C now is C bar. So that's why I said to you, sometimes we can like confuse. Where is rules I need to apply? Then if you know already or normally like this, I can apply this rule number 12. It's easy one. So from here, you're going to see You got A. What is A? A plus, sorry, you get this. I want space. I want space. Wait, here, can I go down? Okay. From here, my A will be A plus B. So equivalent A plus BC equal to A plus B factorize A plus C. This is POS term. So my A here, A will be A plus B. And I will plus with my, B. What is my B? My B is C. Then multiply with my A is A plus B and multiply with my C. What is my C? Which is C bar. Then this is my answer from this part, which is for my ABC. So from here, I have A plus B plus C, A plus B plus C bar, and this is my sum 1. And this, I'm going to get A plus B bar plus C bar for this part. There is no bar. So this is the standard form for this Boolean expression. I use the rules number 8. I use rule number 8 and then I apply rules number 12. Pening tak tengok? So I apply rules number 8 and 12. So let's take a look the example. You were given with this POS. For term 1, what you're missing? You're missing the D. For term 2, you're missing what? A. For term 3, it is standard. Now, how to do this term? A plus B bar plus C. I'm going to add with 0, which is D dot D bar. By getting this version, I'm going to apply A plus BC equivalent to A plus B, A plus C for my rules number 12. Now my A will be this one. This is my A. My B is this. My C will be this. So my final answer converting using rules number 12, I'm going to get A plus B bar plus C, which is my A. Plus with my B here is D. Now I have A. A plus B bar plus C plus with my C. What is my C? My C will be D bar. Finish for my term 1. I got 2 sum terms. You can see here because I'm missing D, only one variable. Now I have term 2. My term 2 is B bar plus C plus D bar. What I'm missing? I'm missing the A. So I'm going to do rules number, forgot already. Rule number 5 ah. Rule number tak tahu. A dot A bar here. I will get the similar things for rules number 12. This will be my A. And this will be my B. This will be my C. So I'm going to get this value, this form of looks because I want my POS, right? So my A will be B bar plus C plus D bar plus with my B. What is my B? Is A here. And I have another one. B bar plus C plus D bar for my A. Adding with my C will be A bar. So finish also. So you combine, you add this, you add this, you add this, you add this, and your term 3, you get the standard POS. Let's take a look in a proper way. So it's mentioned what variables we have, A, B, C, D. What is you're missing? You're missing D here. You're missing A. So how to do it? You apply rules number 8, apply rules number 12. Term 1, what you missing? D. You multiply here, you get this. It is supposedly to be 0. That's why it doesn't affect the value. You can do this. And how you can solve this using rules number 12. This will be A, this will be B, this will be C. And when you convert, you're going to get A plus B, A plus C using your rules number 12. That's why you will get this is as A, this is B, this is A, this is C. For term 2, you are missing A. That's why you're going to add with A here. Then you do similar thing, rules number 12. Rules number 12, this will be your A. Sorry. Wait. This will be your A. This will be your A. This will be your B. This will be your C. You add B plus A. Here is C plus A from your rules number 12. This is your rules number 12. Again, you just apply, then you get the answer. Your final answer will be combination of this. 1, 2, 3, 4. And finally, your final answer for your term 3 is here. So any question? Do the standardization for your POS. No question?
Doctor, why do we do these though? Like, if we were to use the original Boolean expressions, wouldn't the circuit be much shorter?
We need to know the standard form because when we know the standard form here, we can like easily draw the truth table. From this, right, we'll get 1, 0, 1, 1. When at this part, your output will be 0. So just in terms of to get the standard version to see the output later on. From the output later, you can also like having several other things.
Okay, doctor.
Okay, thank you. Because this one is not going to be like simplify, right? Simplify is you're going to like getting very easy circuit and so on. So you can like reduce the numbers of gates, numbers of inputs, number of wires. But that is in the different way. This time we need to know on the standardization because we want to get the output of our truth table. Okay, now there is no more question. This one is also similar. You can try to do it. It's very simple, basically. Here is the part for you to change your mind. You need to switch now. Please switch your mind. Last time under SOP, you already know that A equal to 1, A bar equal to 0. Your output will be 1. delete this from your mind. Now you need to focus on POS. POS, A will be 0, A bar equal to 1, your output will be 0. So from here, I don't think that it's good for you to see this. Uh, you can see that you have this example. If you have POS, what is the meaning by A? It is 0. What is the meaning by B? It is 0. What is the meaning by C? It is going to be 0. This one is 0, 1, 0. For this value, if you have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. At 0, 0, 0, your output will be 0. At 0, 1, 0, your output will be 0. The rest will be 1. Just looking at this POS Boolean expression. So you can like get 1 minute truth table from this Boolean expression. The rest will be 1, 1. How to justify this? Similar to last example I give you, which is 1 by 1. Maybe I'm going to shortcut using 2 input only. Okay, let's say we have only A and B. We have F equal to A, B, sorry, this is POS. A plus B, A bar plus B. Okay, let's say this example. Let's take a look what is basically happened here manually. No need for, let's say if we like directly look, we can say, okay, at the condition of 0, 0, I'm going to get 0. At the condition of 1, 0, I'm going to get 0. The rest will be 1. Of course, right? Because you already learned on fastened way. But how to justify? So justify it. Let me try to show it one by one. First scenario, 0, 0. 0, 0 for A and B. So if it is a 0, 0 here, you add here and then you have another one, 0 bar plus 0. Here you get 0, multiply with 1 plus 0, you will get 1. 0 plus multiply with 1, your answer will be 0. So here will be 0. Number 1. So number 2, 0 and 1. A is 0, B is 1. You adding. This one is multiplication. 0 bar plus 1. I'm going to get 1. This one is multiply. Oh Allah. Multiply. Here is 1 plus 1. I get 1. 1 dot 1. I will get 1 for my output. That is second. And third, my condition now is 1 for A, B for 0. 1 plus 0 multiply with 1 bar plus 0. I will get 1 plus 0. 1 plus 0 is 1. 1 multiply with 0 plus 0. I will get 0. 1 dot 0. So my output will be 0. Another one, last input. Last input, A is 1, B is 0. 1 plus 1 multiply with 1 bar plus 1. Here I get 1 dot 0 plus 1. Here I will get 1 dot 1 equal to 1. So here I'm going to get 1. This is manually, which is when you do it directly. Here is 0, 0. You will get 0. And here is 1, 0. You will get 0. Why this one is 0, 0? I already mentioned this one is POS. You need to change back your mind. Here you're going to have A equal to 0, A bar equal to 1. To apply direct things. When you apply manually, of course, you just need to know it's like answer one by one. But to apply it directly, you need to think about this one, f equal to 0. In equation, hello, any question? No.
I
Yes?
think clear, doctor.
No, doctor.
Okay, thank you. Now, you can see from this, you are given the POS. If it is a standard, you can like directly apply it. If the condition is 0, 0, 0, 0, your output will be 0. If it is a if it is a 0, 0, 1, 0, your output will be 0. And is it this is bar? All the bar is already missing the place. So at the condition, I think at the below one, at the condition of 0, 1, this one 1, 0, you will get 0. 1, 1, 1, 1, you will get 0. So I don't know what else. Okay, this one is 0, 0, 0, 0, 0, 0. Because all the bar is already missing the press. So now you can directly get the output of 0. Of course, your output 1, you know, the rest is output 1. So simple and easy for you to draw the truth table. No need for you to apply 1, 1, 1, 1 time to get the output. So you can see you can directly get, instead of you not apply directly one by one. So that is on the how to draw the truth table. Okay. Just now your friend said why we need to like learn on standardization form and why we need to learn from the standard POS and SOP. Why we need to learn standard and draw the truth table. Later you're going to apply. But now over here, you're going to see sometimes we are too lazy to write too long for you. That's why we want to use a short form by using a notification. Please make sure for S or P, it is only sigma. And this is the symbol of sigma. When you look the sigma, you need to know this is S or P. While for POS, we're going to use pi. And when you look into pi, you know it is POS. Okay, let's take a look one by one. If we have here sigma A, B, C, 2, 5, 7, what is the meaning by this? Last time you were given with the Boolean expression, you already understand directly. But from here, first thing you know, okay, sigma is SOP. 1. Second, you were given with this. This means that you're going to have three variables, which is A, B, and C. And from three this variable, you have 2, 5, 7. SOP, your output will be 1 when you meet the condition 2, condition 5 and condition 7. What is this condition? You convert this decimal to binary, you will get 0, 1, 0. This is one condition. Second condition, 1, 0, 1. Third condition is 1, 1, 1. So when you have made this, your output will be 1, 1, 1. So if you have truth table, you can like easily directly get 0, 1, 0 is 1, 1, 0, 1 is 1, 1, 1, 1 is 1. The rest will be 0, 0, 0. And what from this, what is basically your Boolean expression? So from here, you're going to see this is A as 0. For SOP, it's going to be A bar. B1 is B, C0 will be C bar. Plus, second, A, B bar, C. Third, A, B, C. So any question from this? Easy, right? So you need to remember that for SOP, I already repeat several times. A will be 1, A bar will be 0. So when you play around with SOP, you will use that term. So when you have like 0, 1, 0, you know 0 will be A bar. B will be B. 0 will be C bar. So now, that is on your SOP. POS. What will happen? You're going to use a pi notification. If you were given with this, you have x equal to pi a, b, c, 1, 4, 6. Again, you know this is POS. How many variables? You're going to have 3 variables, A, B, and C. And what condition you will get the output of 0, because this one is POS. So you get output of 0 when you have the condition of 1, 0, 0, 1. 2, 1, 0, 0. 3, 6, 1, 1, 0. Why is this? You convert 1 to be binary. You convert 4 to binary. You convert 6 to binary. You will get this value. And what is this representation? Please bear in your mind this condition, which is A bar is 1, A is 0 for POS. Now you have A plus B plus C bar for this condition 1. For second one, you have A bar plus B plus C. And the third one, which 1, 1, 0. 1, 1, 0 is A bar plus B bar plus C. This is your POS or your Boolean expression, which is similar to this. So is it okay or not? So if there is no question, because all of you like keep quiet, you can see also next. We have several examples for your notification. Here represent the following Boolean expression as a sigma notation daripada from your SOP. From your SOP here. Let me try to draw sigma first because it is SOP. And then I have 1, 2, 3, 3 variables I'm going to put here. And in what condition I will get the output as 1. So let me take a look into my condition. Under SOP, my A will be 1, my A bar will be 0. Then I will get first 1, 1, 0. Second, I will get 1, 0, 0. And the third one, 0, 1, 0. So I convert this to my decimal. I will get 6, 4, 2. 2, 4, 6. Then, ting ting, correct. I get the correct one. That is on my SRP. Now, second, I have by notification. Okay, I drop by. How many inputs I have? I have ABC. Okay, A, B, C. In what condition I will get the output of 0? Okay, POS. I need to remember back. A equal to 1, 0. A bar equal to 0. A is equal to 0. A bar equal to 1. So here I have 0, 0, 0, 0, 0, 1, 0, 1, 0, and 1, 0, 0. So from here, 0, 0, 0, 0, I get 0. 0, 0, 1, I get 1. 0, 1, 0, I get 2. 1, 0, 0, I get 4. So my answer will be correct. So this is how from Boolean expression you get the sigma notification. From sigma notification, just now you already look into how you get the Boolean expression. And you can also get all the truth table by this sigma and also by Boolean expression. So is it okay?
Okay, doctor.
Okay,
Yes,
okay.
doctor.
Okay, now let's take a look into next. This one is also exercise you can try to do. It's very simple, easy peasy, easy peasy. So from here, you can convert it to be a decimal, binary. You will get 111. This one you will get 100. This will be 011. A, B, C. You can see here. And this one is your SOP. SOP A equal to 0. Ayu. A equal to 1. A bar equal to 0. Then you will get A, B, C. Here is A, B bar, C bar. Here it will be A bar, B, C. And you combine it together, you get your SOP Boolean expression. Okay, please try to do so. And similar to this, pi, which is POS, you have similar thing. 111, ABC, 100, 011. So how to represent it? Need to remember A equal to 1, A equal to 0, A bar equal to 1. Then I have A bar plus B bar plus C bar. Here I get A bar plus B plus C. Here is A plus B bar C bar. So I combine it together, I get my POS. Easy peasy, easy peasy. Now, uh, I cannot understand sentences. You can try to read it. In terms of blah, 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 whatever it is, you can also go through. Now I directly to example here. You can see Convert the following SOP. Now it is time for you to know, oh, Doctor, now I know why I need to learn the standard version. From this SOP, you need to convert to POS, or from POS, you need to convert to SOP, vice versa. In this question, in this example, it gives you the SOP. From this SOP, tak perlu, no need for me to show you manually. Directly, you can see, okay, when your output is 0, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. I'm going to get 1. 0, 0, 0, 0, 1. 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. Now I have, this is 1, this is 1, this is 1, this is 1, this is 1. The rest will be 0. Now I get this truth table from this Boolean SOP. How I'm going to get the POS? After I draw the truth table, I know this will be my POS, this will be my POS, this will be my POS. Then you know, oh, it's good for you to know the standard of SOP, the standard of POS, because from here I can like mm, convert from SOP to POS. Now my POS is A plus B plus C bar. Second, I have A bar plus B plus C. And another one is A bar plus B bar plus C. This is my POS from this SOP. Okay, that is the things that you need to know, why you need to learn all of this. Now let's take a look. Let's give you several steps. If you have A, B, C, you have 3. So there is a 8 possibilities. But over here is already occupied 1, 2, 3, 4, 5. Then you can draw the truth table from here. There is another left 3. 1, 2, 3. From this will be 0, 0, 0. The rest will be 1 right from this. So for this 0, 0, 0, you will bring it down. You get your POS. That's why there is a question. Convert the SOP here to equivalent POS expression. Then this is your answer. Oh, this one, you have convert the following SOP to equivalent POS. This is not standard. Then that's why you need to know how to standardize it. Because now you said it's going to be like quite long, and then of course it's not going to be like good for you also, right? Because you're going to add another gates, add another, and the whole, your circuit will be also complicated. But in terms of converting SOP to POS, POS to SOP, you need to have the standard version. Then you know how the truth table look like. From this, you can convert it to be a C bar. Over here, it is not enough the B. Then you have A C bar, B plus B bar, plus B C bar. I'm going to speed up, okay? I hope that you understand. A plus A bar. Here I will get A B C plus A B bar C bar plus A B C bar plus A bar B C bar. From this standard SOP, I can directly draw my truth table. Okay, this one. This one. This will be 100, 1001. This one is 110, 1101, 010, 010 here. The rest will be 0. So the one after I get this truth table ABC, the question asks me to convert to POS. So my POS will be this one, and this one. So I convert it to be using POS. I'm going to get A plus B plus C, and what else? This A plus B plus C bar. Another one is A plus B bar plus C bar here. And another one is A bar plus B plus B bar. So then no, okay, combine it together, you get your POS. That's why it's very easy also. After you know the standard. So this one is the reminder. Tiga eh. Is it three? Oh, just now I get four. See, maybe another one is similar. Wait, I check back. C bar plus A B bar C bar plus this one I will get A B C bar plus A bar B C bar. Which one is similar? Oh, this one. Just now I wrongly key in the value, I think so. So I will get A, B, C bar. Here I will get A, B, C plus A bar, B, C bar. So after I know the value, the rest will be my POS. So you just convert it using the POS. A equal to 0, A bar equal to 1. Okay, so any question? Any question? This one, Boolean expression. I want to finish until this. Can or not? Can I continue? One is similar things. Okay, I will continue, okay?
Okay, doctor.
Okay, thank you. Boolean expression and truth table. Similar also. You can see product is equal to 1. You're going to use for SOP. Product sum will be 0. You're going to get POS. If you have this truth table, you can see this is for your SOP, for your SOP, for your SOP. You're going to tag all these 000 to your POS. So you can see this is your POS, you're going your POS over here. So how are you going to convert this one also? We already take a look. If A is equal to 0, B equal to 0, C equal to 0, and you need to remember the condition of POS will be A equal to 0, A bar equal to 1, and your output will be, Ya Allah, mana dia pergi? Your output will be 0. This is POS, and for your SOP here, your SOP A equal to 1, A bar equal to 0, your output will be 1. That's why you look into 1 only. So this is the correlation between your truth table and also your Boolean expression. And you can try to do the exercise. Basically the similar things here. Okay, it's give you directly. Let's say convert to binary value of your SOP. Convert the binary value. So from here, you were given the binary value of your truth table. Convert to SOP. Of course, it's very easy. You just look into SOP is F equal to 1. So from here, you just convert the terms. Where is another one? A, B, C. So you will get the S or P. You can also convert the binary value to the product sum of term, which is S or P. So you can bring this one to be the S or P. So convert the value to be POS. So you can directly convert. It is not too hard for you to do so. So until here, I guess next after this you're going to play around with your camera, but it is in our class tomorrow. And I already mentioned to you the care map is a solution for you to know what is the simplification version for long Boolean expression. If you are given with the simplification version of a question, of course, you don't have any clue what is your final answer. What is the simplification version? That's why you can check your answer using your care maps. But tomorrow we will look into the care map. Any question?
No, doctor.
No, okay. So I guess we can stop now. For those who still not yet scan your QR code, you can go to the e-learning. I already post out there. For the rest, you can dismiss. Okay. Thank you and meet you again tomorrow. Bye
Thank
bye.
you, doctor.
Thank you,
But one more
doctor.
time. One more time. Tomorrow I got meeting at uh 10. Wait, I got meeting at 10 until 11. I hope that because meeting, right? So I hope that it's finished 1 hour so we can start our class at 11. Anything I will inform you through WhatsApp, okay?
Okay, thank you.
Okay,
Okay,
bye
doctor.
bye.
Thank you.
Okay, bye.
Good, doctor.
Okay, bye bye.
Thank you, doctor.
Thank you,
Okay,
doctor.
bye bye.
Thank you, doctor.
Okay, bye bye.
Thank you, doctor.
Okay,
Thank you,
bye.
doctor.